All right, so good afternoon, everybody. So today we're gonna see what is called random forest regression in machine learning. So let me just start sharing my screen and let me know if you can see my screen from there. Can you see my screen? All right, thank you. Okay, so good afternoon, everybody. So in this tutorial, this is a very short tutorial. Actually, we will not take like much time. So this is just about random forest regression. So there is random forest for classification and for regression. So, but this tutorial will mainly focus on like the regression task. Okay, so let's start by trying to know the main idea behind random forest algorithm. So random forest is a supervised machine learning algorithm that is used for both classification and regression problems, as I said. So you can use random forest in classification problems. Also, you can use random forest in regression problems as well. So the random forest algorithm creates decision trees on the data samples and then gets the prediction from each of them and finally select the best solution by a majority of voting or averaging. So I will just come back to these concepts. So don't worry. So it's an ensemble learning that is better than a single decision tree because it reduces the overfitting by averaging the results. Okay, what I mean, first of all, random forest is a bragging algorithm, like it's an ensemble learning algorithm. What I mean there, so you all know that in ensemble learning, we have many models, like we split our training data into many samples, and then each sample we fit a model. And then what we do is like each of these models will give a predictions, and then we have a generalizer. It means that like we have to like combine all those predictions. If it's like a regression problem, we have to take the average of all those predictions. And if it's like a classification, we just consider the predictions that like occur mostly. Like for example, let's say if you have a binary classification, so we have many models. So what we consider is like, okay, some models are predicted 1 and some are predicted zero. So we just consider those that like if we have more ones than more zeros, so our final outcome will be just the one prediction. So this is what I mean. So this is ensemble learning. So now random forest is like a particular example of ensemble learning. So in random forest, instead of having different models, these models are just decision trees. For example, let's consider this case. In random forest, we have like all those models have decision, like we have decision trees for all those models. We have a training data, and then we split randomly our training data. So let me show you the two concepts of random forest. Like we randomly select the training data for building the trees, and then we randomly select the subset of features considered when we split the nodes. Okay, so this is our training data. We randomly like select some random sample from our training data, and then for each sample we train a decision trees model. For each sample we train a decision trees model. You realize that here we have a training sample 1, training sample 2, etc., up to training sample n. And for each of them we just train a decision tree. Here we have decision tree 1, decision tree 2, decision tree, etc., up to decision tree n. And then each of these decision tree models will generate a prediction. Okay, then what we do is like we just take the like majority of voting. or we just take the average if we have a classification, if you have regression problems. Okay, let me show you this in a more clear way. Here, this is my data, the training data that I have actually like split into many samples. Okay, and each sample I have fitted a decision tree model. Okay, actually I have 4 samples, and then I have trained 4 decision trees models: tree 1, tree 2, tree 3, and tree 4. Right?
Hi, sir.
All
Can
right.
I? Yes. Can I just tell something quickly and then I'm going back? Like, just give me 1 minute to tell them something quickly and then you continue.
Okay, go ahead, John.
Yes. So, hi family. I just wanted to notify you something about the reporting. Like, when you are reporting the digit number, just like stop in like 2 number after the decimal. Like manage to approximate, like not giving all the number after the decimal, like just use significant number. Check this online instead of writing, for example, 2.66666 and a lot of C's. Then like just convert and manage to provide 2.67 depending on your output. So I just we remark that in the reporting side, and I want to quickly share this with you for the coming reporting plan. Yes. So Mustafa, this was what we was talking about
Okay,
just before the tutorial. So I just wanted to do that before because I don't have a lot of energy right now. So that's why I just stopped you. So I'm sorry a lot.
don't
And
worry.
yes, okay, you can continue.
Okay, so guys, I'm sorry for that. So that was just an announcement from John that Aaron has mentioned. Okay, so let's continue. So I was just saying to show you in a more clear way. Let's consider this X dataset that I've actually split it into 4 samples. And then each sample, I have fitted a decision tree model, as you can see. And each decision tree model has generated like a prediction, a class of prediction. For the decision tree 1 has predicted class 0. For decision tree 2, the prediction is class 1. For decision 3, the prediction is class 0. And for decision 4, the prediction is class 0. What we call like, what is the majority voting? Majority voting is like, if you look at these predictions class, you realize that the class 0 is like more than, like is more predicted than the class 1. We have just one prediction about the class 1. So we have like our final prediction, we will just consider the class 0 because most of these decision trees models have predicted the class 0. So this is what we call majority voting. Like we just consider the class that is mostly predicted. Okay, so as you can see here, the final class is just class 0. So this is like the main idea behind a random forest model. If you understand decision trees model, as Sebastian covered last time, so you won't have any issue in understanding the random forest model. Okay, this is a classification problem. Okay, in case of a regression problem, you don't have to do majority voting. You don't have like to select some like prediction and leave out some. What you have to do is like you have to sum up all the predictions outcomes, and then you take the average, and that will be your final prediction. So that's all. So these are the main problems. If you have a classification, a binary classification.
Hello,
Yeah, hello.
hello.
Yeah, I can hear you.
Okay, so my question is this. So basically, like you are training with random forest. Okay, it takes a subset of the data set and some features, its replacement, right? So basically now, so when you are doing prediction, is it that it takes each row into the different trees that have been created? Like let's say the trees, the decision trees are 4, and when you want to make prediction, is it that the thing takes each row of the test data and then passes it into the different trees and then tries to predict the majority by using the majority votes? Is that how it does prediction? Because I get the training aspect, but the prediction aspect, like is it that it takes, can you hear me?
Or do you? I'm sorry. It's like there is kind of noise. It's from your side or someone else.
Hello, can you hear me? Hello.
Okay, so okay, just speak louder because there is a kind of noise.
Okay. Hello, can you hear me?
Okay. Yeah, yeah, it's okay.
Yeah, yeah. Okay. So basically, I said for training with random forest, you take
Yeah.
a subset of the data sets and then any feature, maybe 3 features with replacement and stuff like that. So when you're making prediction,
Okay.
is it that you pick one row from the data from the test data set and pass it into the random forest, and then the random forest split, maybe just takes some features randomly, takes some features and pass it into all the trees. That is, let's say if you have 4 trees now, and then makes prediction.
Okay.
Is that how it works? Because when you say you pass, because sometimes there are some features that might be left out of this stuff, and if you're using 4 trees, and we have, let's say we have features like 8 features in our data set. So how does it actually work with that and the prediction aspect? That is it.
Okay. So here the main idea is first of all you have to do random sampling. So okay, like if you are actually implementing the algorithm, you have to specify the number of features that your samples has to be like have to consider. That does not mean that you for all the trees you're just going to consider the same features. No, this is just random sampling, and most of the time like the random sampling is with replacement. That means some of the features that like have that are used in the first tree might be used in the second tree, but not like all of them. Some of them might just come again, but it will take other features again. So the number of rows also is just like random. They are just like you just select randomly, right? And then it's not like the sample that you fit your model one will be used for the sample that you will fit for your decision tree two, and etc. So you have a data, you just like split your data into many samples with replacement, and then you have different samples. The number of samples depends on the number of trees you want to use. So you can, like, we might use like 4 trees or 6 trees, it depends. In this case we just have to do like to split our training data into 6 or 5 samples, and each sample we fit a model, and that model will generate a prediction. Like this is like we are actually training the model on the training data. Like we are actually training the model on the training data, and each model is trained on one sample, each model is trained on one sample, each model is trained on one sample, and then each of them will generate a prediction from the sample that it has been trained on. And then we now have to take like a decision. Okay, if it's a classification, you cannot just average, because if you average this you will have something like a flat number, right? So what you have to do is majority voting. Like you just consider the class that is mostly predicted. That is your final class. Okay, in case of a regression, uh, you don't have a class. You don't have like to do what is called the majority voting. You just have to take the average. You just sum up all of them, and then you divide by the number of trees that you have, and then that is your final outcome, your final prediction outcome. So I don't know if I have answered your question or not.
I'm talking about the test. You have
Yeah.
answered the question about the train, but the test. I don't know.
Hello.
Hello, I said you have answered the question about the training, but what about the testing?
The test
So,
set.
yes,
Okay.
how
The
does it
test
work
set.
on the testing?
Yeah. Okay. The test set also is like the same. So you just have to like to fit. Now your model is your random forest is like already trained. So this is just consider this, all of this as like a model, and that model is the random forest model now. All right, and then this is the final outcome, right? And then you have to consider your training data, and it will be the same for your training data. It will do it automatically, like for your test data, sorry. It will do it automatically when you put like the test data. It will be your test data will be split up to like the number of like trees, and then each of them like you will just give something. All right. And then, but as you already build your model, so you will just now have like, for example, one outcome. So, and then that outcome, there's some like prediction that the model fails because it is not perfect at 100%, but at least like the accuracy will be higher because when you were training the model, you consider the class that was mostly predicted instead of like the other one. So that means if now you apply on the test data, your model will like perform better, like comparing it if you like would have taken like the other class. So the idea is the same. The way you use like your test data, you can just use the way you use your train data to feed your model, to train your model. You use can do the same like to test your model, the performance of your model. You know, so I don't know if I answered your question.
Okay. Yeah. Thank you.
Maybe
Thank
I
you very
don't get very well your question.
Thanks. Thank you very much.
Okay, or someone has a question, or maybe someone want to add some comments. All right, so this was just the main idea behind a random forest, right? So let us jump into the coding part. And here in this section, we will be using the Boston data for running the random forest regression model. Here we have a regression task. So the dependent variable here is the price of house, and the objective is to predict the price of house and on the basis of the independent variables. So here I have just imported some couple of libraries that I will need, right? So here I have loaded the data. So you can get this data from Kaggle or in this way. So it is like on the data that is available. All right. So this is the data actually. This is the price. It's you see, it's not a binary problem. So I'm trying to make a regression, like to predict like the price of this data set based on some other features, right? So here I have defined my train and my test data, my like features matrix, like my features and the target variables. X is the target variable, Y is the target variable, which is price. And then I have splitted my data into training, testing data. As I told you, like you see, I have X train and X test. The same thing will be like applied for your training data. You have Y train and Y test, for example. All right, and then this is like the size, and these are the parameters that you have to set. All right. Okay, so here I have to initialize my model. This is like a random forest regressor, and I did not put anything. And by default, like these are the hyperparameters that he has generated. Okay, now by default, if you don't set anything, it will set like the default values for you. Okay, you can have this link. It will show you like the definition of each hyperparameters here in details. Like you will find everything here in this link, the definition of each hyperparameters in details, right? Now we start predicting. Okay, we have fitted our model into our training and into our like X training and Y training. Okay, then we try to make now some prediction. Okay, so here you see we did not set anything. It does like it just gives us the default values for these like hyperparameters. Okay, so when I check the score, the accuracy of this model, I have something like this. Okay, so the accuracy of this random forest is like let's say 82%. Okay, now let us move on to what we call turning hyperparameters. Here we have like selected some couple of like hyperparameters, for example, max deep, max features, like the number of features, the minimum sample, the split, and the minimum sample lift. And as I said, you can check all of them, the definition of all of these hyperparameters here. I don't want to waste time. All right. And then we have what we call like grid search. Grid search is a way of for you to know the best model. Like the model will just select, depending on your problem, the model will just select the best hyperparameters for you. Okay, for example, the max depth here, we have a range. We have here 3, 5, 6, 7, 8, 9. But actually, we don't know which one of these will be like the best for our model. The maximum of features. Okay, we have auto, square root, and log normal, log 2. Okay, so let me just show you, for example, here. Okay, the maximum number, the max features here, it just returns the number of features to consider when looking for the best split. Okay, you realize if it's auto, then the maximum feature is just the square root of the number of features we have. If it's square root, it's the same. If it's log 2, then it will just take the number of features and compute the log 2, and that will be the number of features, like the maximum number of features. Okay, so that's what I mean. All right, so now let's initialize our model based on the grid search algorithm. Okay, here I have model random forest, for example, grid search. Okay, grid search, I have to use this function, and here you have to put as argument your model that you already fitted. Okay, remember my model was rf underscore model. I have to put my model, and then grid parameter, for example, grid search parameters, for example, that I have defined it here. All right, so these are the parameters that I have defined it here. I have defined it here. So what it will do for us, it will, for each of them, it will just give us the best for our model, right? And then I have to take this and fit it into my like training and testing data, my training data, X train and Y train. And then you can check now the best parameters for you, all right? By using this is the model, and then dot best parameters underscore, right? It will gives you this. That means that for maximum depth, the optimal number for our model is 9, right? For maximum of features, it's auto. For minimal sample leaf, it's 1. For minimal sample split, it's 2. And this is now like the best model that you have, considering these hyperparameters, for example. And then you can use this model now to do your prediction. Remember, here I did not do this whole work. So because I leave it like that, I just have the default values. But here I have set some numbers, and I use the grid search algorithm for it to give us like the optimal values for this model based on our data. So this is like the optimal values for each of these hyperparameters. So, and then we use this model to give a prediction, for example. Okay, here we have like this model, we have just to predict, for example. And if you look at the accuracy of our prediction, it's like that. It's not like that much far from the one we got earlier. So, but it's always better for you to maybe use grid search or maybe random search, because you want to know which values is optimal for this model. But random search will do it automatically for you by considering like a set of values that you already have, and then it will gives you the best of them, and then you use that final model to do your prediction. Actually, now you know that based on your parameters and your data, this is the best model you actually have with the best hyperparameters. So this brings us to the end of this presentation. So thank you very much.
Hello.
If you have okay, hello,
Hello.
hello, yeah,
Hello.
hello, I can hear you.
I think Gerard has go. After Gerard, I will speak.
Huh?
After Okioma, I think Okioma wants to speak. He wants to ask a question.
Oh, yeah.
Oh, okay, okay.
Hello, everyone.
Hello.
I just had a question on the working of the random forest.
Okay.
At the beginning of the slide, there was this presentation where you had like you have the training data, then you split it into samples.
Yeah.
Yeah. After you split it into samples, yeah, I think this one. So you have sample 1 in decision tree 1, then sample 2 in decision tree 2, like that up to the last one. So how is the voting done, or is it that you have the same sample, like training sample 1, and then it's done by, let's say, 4 or 5 decision trees, or like 4 or 5 models work on that sample data, and then they vote on the best prediction for that particular sample. Because like here now, if sample 1 and sample 2 are different, how come they vote on 2 different things? I don't know whether you get me.
Yeah, I understand. Here, it's not like we will use one sample for all the trees, and then we come back and take the second sample and use it for all trees, and then we come back and take the third sample and use it for all trees. No. So each sample is only used for one decision tree here. But we do the sampling with replacement. That means some features or some rows from the previous sample, some of them, not all, some of them might be in the second sample. But that is like just for the next model. And then for the third tree, we have another sample, the third sample, for example. It's like each tree here has its own samples. Now, some elements or some records or some features from the previous samples might be repeated in the second, in these current samples, but not all of them. Still, the samples are different, right? And then each of them, we train our decision tree model, and then each decision tree will give out a prediction class or a prediction, like if we are dealing with a regression. And then from there now we do what we call voting, because I get your point, like how comes we do voting on things that are not the same, but the whole idea is like the training data is the same data, right? We have like one training data set. Yeah. And then we can have in mind that we have the same, they all have the same distribution, because we just take them from the same training data from the beginning. And then the fact that we do this with replacement, that means like we can still like we can avoid having that problem that you are saying, like if things are not different, how can we do voting on those things? We still do replacements, so means like the samples have somehow correlated, because some features or some records from the previous samples might be present in these samples, and then in the next sample, and so on and so on. But the main idea is like we have one training data from the beginning. We have one training data, and we are sampling from the training. The thing is, we are not sampling from different training data. So we just have, at the beginning, we have one data, and then we are sampling from there, but also we are doing the sampling with replacement. And then it's not like we use each sample for all the trees. No. For each sample, one tree. Each sample, one tree. And then those trees are trained on those samples and then gives prediction. And then now we take, if we have binary classification, we take just majority voting. For example, the class that is mostly predicted. If we are dealing with regression task, we just take the average. So that's it. So I don't know if I answered your question.
Yeah, some, but I think with time I'll get to understand it better.
All right. Other question?
Hello. Hi.
Yeah.
Thank you for the tutorial.
Yeah.
So I have just one question. Like if you scroll down your notebook,
right.
The part where you specified the max depth and like some variables like that. So like, is there a way we can be like the model can actually generate it for us rather than us specifying? Because I truly don't understand the numbers that are there.
Oh, the numbers that are here. Okay, for example, okay, what does it mean is that max depth like should take an integer number, right? You could have specified just 3 or 9 or any integer number. Okay, now that you are not sure which integer number is like the optimal max depth number for this model, you just like specify many. You just put like you have this many of them. You could have like specify 3, 10, 2, 1, etc., etc. It depends. So this is just a way to show you how green chat works. And I did not specify all of them, all the hyperparameters. There are some hyperparameters that I did not specify here. For example, if you see here, I did not specify the maximum max sample, like what should be like the maximum sample, for example, and you have integer. Okay, so you could have specified that one also. Max features, I have shown you here. I've shown you here. For example, max features, it takes these parameters: auto, square, log2. But actually, for your model, you don't know if auto is the best for you for this model based on this particular data. You don't know if the square root, for example, is better for this model with this particular data. You don't know if log2 is the best one, the optimal one. So you just have to leave it like that. That's why I set it like that, all of them. The grid chart will give me the one that is like the optimal for this model, right? Also, the min sample split just should take an integer. Okay, now that I don't know which integer is the optimal for this model, I have specified like sum. You could have just gone far, right? 10, 11, 4, 1, etc. It depends. So this is just a way to show you how the insert works actually. Okay, the same as these hyperparameters. Parameter, it should take like an integer. Now that you don't know which integer is the optimal one, you just you have specified some of them. Okay, I could have added, for example, 7, 9, 10, etc., etc., etc. So this is like the main idea behind this. So I did not set all the hyperparameters. So I just put some of them here to just show you the main idea behind green chart. Now, what grid chart does is that based on these hyperparameters that you have set here, it will just give you the optimal ones, like the ones that are really better, like the ones that are optimal for this model based on this particular data that you have fitted your model, for example. And then using this, for example, best underscore parameter underscore, it gives you for each of them, it gives you the optimal one. The max depth, for example, you see, I had 9, 8, 7, something like that, but it says that 9 is the best one. All right. The max of features, it said auto is the best one, and the number of sample leaf is saying that 1 is the best one, and the other one is saying that 2 is the best one. You could have like specified more hyperparameters, and also you could have like added more integers here, and grid chart will just give you the best ones for you, the optimal hyperparameters for you. So this is the main idea behind this. I don't know if this has answered your question.
Oh yeah, thank you so much. Yeah, thank you.
All right. Any other question from anybody? Actually, random forest, if you really understand decision tree, random forest is just like you just combine many decision trees. That's all. And then your final outcome, you have just to consider if it's like a binary classification, you consider the class that is mostly predicted. And if it's a continuous problem, you just take the average. Okay, someone wants to talk?
Yeah, sorry. I think let me just go over. There's some things that are still confusing. I'm saying I need to understand. So basically, hello.
Yeah, I can hear you. Yeah.
Okay. So basically, when you look at the random forest, so now let's take for instance now the training data is passed into this random forest model. So basically, the training data will take. Okay, yeah. So basically, the training data will take the sample of the data set, right? And then the model will pick from a sample of the training data.
Yeah.
And then feed it into the first decision tree. And then you may piece another one, a different one, or maybe one that just have a similar feature into the second tree, right?
Yeah, that one because we are doing sampling with replacement. That's why some of the features there might be repeated here.
Yes, I get that one. Then the model, then the decision tree 4, right? Or the last one. So basically, my only issue now is basically like, okay, so now when you train with this first sample, you train with the second one, you train with the third one, you train with the fourth one. So basically, that means they bring their results together, right?
Yeah.
So basically, that means they bring their results together, right? So basically, that means they bring their results together, right? So basically, that means they bring their results together, right? So basically, that means they bring their results together, right? So basically, that means they bring their results together, right? So basically, that means they bring their results together, right? So basically, that means they bring their results together, right? So basically, that means they bring their results together, right? So basically, that means they bring their results together, right? So basically, that means they bring their results together, right? So basically, that means they bring their results together, right? So basically, that means they bring their results together, right? So basically, that means they bring their results together, right? So basically, that means they bring their results together, right? So basically, that means they bring their results together, right? So basically, that means they bring their results together, right? So basically, that means they bring their results together, right
Yeah.
So the thing is, how do they do this majority voting? Because if you look at it, the samples are quite different. Like the samples are quite different. They are not the same samples. So how did their majority voting occur? That's just my only issue. I don't know. Maybe I will still go over it.
Okay. Okay. I think someone has asked a similar question. Here, the thing is, we are not sampling from a different training set. For example, we have like one training set, and then we are doing the sampling with replacement. It's a kind of bootstrapping, for example, right? You do like sampling many times with replacement, all right? So here we don't have like the samples don't have some particular like character or things that the other ones don't have. For example, we are just like we do sampling from the training data, different samples that correspond to the number of trees, and then we build our decision trees on each sample, right? And then each decision tree will predict from the sample that he has been trained on, right? And then it gives out the prediction. So that is the reason why like we just combine those results, because now we have results in many samples, for example, and then
Okay, clear.
we combine the results. That at least
Thank you.
did you get the point?
Yes, it's clear now. It's very clear now.
All right. So okay, someone else, if you have question. Okay, if you don't have question anymore, so let's stop here because you don't have much time. You have to finalize your challenge. So thank you very much for attending.